name is Dana Golden. Welcome to Environmental and Natural Resource Economics. We're finally on the last unit of the environmental economics section. This is the last thing we'll talk about before we transition to natural resource economics. And today we're going to talk about environmental data and analysis. This is the portion of the class I think a lot of people will see as a digression. I think a lot of people are going to question, like, why are we talking about data? But the truth is, data in economics is a very important part of essentially any modern work. I think most of you will end up with a job title that sounds like junior analyst or consultant, and you're really going to need to have data skills. So I really do believe it's our job as teachers to provide you the skills you'll need to work. And right now, when you work, you have to do a lot with data. So what is economics about, really? Is it about the stock market? Is it about money? Is it about the economy? Is it about consumers, business and profits, policy? No, it's not about any of these things. It's about a particular kind of scarcity. I think when a lot of people go home for Christmas and Thanksgiving, especially probably if you're economics PhD students or economics students, I guess you're undergrads, you're taking this course, but if you're going home for Thanksgiving, you're going to be asked about the stock market. You're going to have your uncle say, hey, Dana, what's going on with the stock market? And you're going to be expected to have a response. You probably are not watching the stock market, because that's not what economics is about. But the general public does not really realize that. Economics is about how individuals make decisions about trade-offs between finite resources and infinite desires. It's about how you deal with the fact that you have these limitations and you need to optimize your welfare subject to certain constraints. Economic decisions are about trade-offs, human decision, human interaction. This is very important, and these two things are what makes economics so special. Because economics is not engineering. Fundamentally, if you're doing work where you just run an optimization routine and you say, here's an algorithm to optimize this thing, you're not doing economics. Economics is about human decisions and human interaction. So it's a very human thing in a way that I think very much distinguishes it as a social science, but it's also a very mathematical thing. It's about the optimization of mathematical functions that makes it a very interesting, unique thing. So what is an economically interesting research question? So first off, economically interesting research questions need human action. Like we said just now, you cannot be doing economics if you're not thinking about what someone is doing. Someone needs to make a decision about something, preferably requiring a trade-off involving the optimization of resource or some kind of allocation. Economic questions are motivated by theory. We are not regression jockeys. We are, as economists, making decisions about how we think about the world and thinking very specifically about our vision of the world. A model is an opinion with some math. So we as economists do a powerful thing where we think about the modeling, but we also perform statistical analysis that a lot of computer scientists and data scientists are not doing. And economically interesting questions are novel and non-obvious. If there's an economic agreement and lots of evidence that two variables interact in a particular way, new evidence isn't particularly interesting. It might be cool to analyze a new policy without an interesting connection to theory. I don't think anyone's going to care. I think they might be like, yeah, this seems cool, but it's nothing particularly new about that. So some characteristics of good research questions, and you should be thinking about this as you're going into your final project, if you choose the final project option. Good research questions are specific. They're specific enough that they can be answered and focused on situations with many assumptions. You want to ask a very specific question, get a specific answer, because the greatest challenge you can make is asking a very general research question, not being able to get an answer. Research questions are falsifiable. Your hypothesis should be able to be proven wrong, and evidence can be found either way. Good research questions are data-driven. You should understand what data exists and what estimation might look like before starting a research question. This is, a big part of feasibility is understanding data. Good research questions are novel. They do things that have not been done before, but usually build strongly on existing literature and models. And finally, good research questions are literature-driven. They're aware of techniques in the literature and how they can be improved and built on. So examples of environmental economics research questions. What is the impact of policy uncertainty on the decisions of coal generators? If we have the possibility that one day Barack Obama is going to come in office and be like, no, I'm stopping coal, and the next day Donald Trump's going to be in office and I like coal, how does that affect what coal generators are going to be doing, not knowing what policies are going to be following? What is the best technique for valuing water rights in the Western United States? A lot of my friends work on water rights. I don't, so I'm not sure. I don't know a lot about water rights, but if you want to learn about them, I can connect you with some people. How do carbon border adjustment mechanisms impact international trade? There's this idea in the EU that they have carbon taxes, but there's this worry that you're just exporting the carbon-intensive activities elsewhere. But how would a policy to stop that leakage of carbon impact international trade? What are the macroeconomic impacts of carbon taxes on economic growth? In this particular case, it's economic growth. I maintain this is not a typo. I'm very interested in growing the economy. And what is the impact of increasing transmission on generation investment in electricity markets? I think there are a lot of people right now thinking about, if we build out the grid, what will happen to investment in generation in the electricity market. I think there's tons of people working on that. What is an economically interesting question in business? So that was research. In research, there are very particular specifications about what an economically interesting question is. In business, economically interesting questions are much more broad. They're not necessarily solely about doing interesting novel things. They're about answering questions people have. In particular, in business, theories of human behavior are much less important than empirical predictions. People in business don't really care about why things happen. You should have a generally valid theory, but you want to be more making empirical predictions and providing evidence as to what will happen and what the outcome will be. Forecasting is almost anathema to traditional economics, but central to analysis in business. I saw someone recently present a very good, I think, forecasting paper in the macroeconomic workshop that focused on using large language models to forecast the prices of commodity futures. That was not particularly well received in terms of an economic setting because most economists don't really care about forecasting. They want really valid and well-developed models. A good thing to say is, that works in practice, but how does it work in theory? In business, you don't really care about great modeling. Research in economics requires interesting, complex new techniques. Research in business often uses boring techniques because they work and are easy to explain. In research in economics, you're going to be probably led to believe that you need to do a lot of stuff with instrumental variables. You need to do a lot of structural econometrics. In business, very often a linear logistic regression is great. Quite often you will pick simpler models because they're easy to explain. And finally, business analysis often focuses on price and demand forecasting, understanding customer behavior, and cost-benefit analysis. You're answering a very specific question with a result being, what should we do? So what does a request from a manager look like if you're on your first week as a junior analyst and the manager comes up to you? It'll be something like, hey, Dave, I was wondering if you can come up with characteristics of customers who predict who buys. How do we know who buys? Hey, Sarah, could you run the numbers on projections for revenues and costs next quarter? Could you come up with a valuation for this project? Often these are very vague and open-ended with faster timelines and more specialized data. In my dissertation, I'm taking 5 to 6 years to write one paper. I think that would be very, very rare in business. I don't think I've ever met anyone who was in business and had their boss ask them to do something 5 to 6 years. I think most of them would consider that insane. Unless it was something very long term in terms of research. So business timelines are very fast. Explainability is very important. Overly complex models are frowned upon. And results should be succinct, actionable, and visualized. So some examples of environmental economics business questions. What is the net present value of this wind turbine? How sensitive are your estimates to wind interest rates? So maybe Ørsted or Eversource is going to come up to you and say, how should we think about the risk of rising interest rates on wind farms? Spoiler alert, higher interest rates are bad for wind farms. How should we think about environmental damage and mitigate the cost of the damage we cause? Some businesses really do care about stopping pollution or want to demonstrate to others that they do care. How should we price this flood insurance product? How will those prices change with interest rates? And also climate risk. This is something I think goes back to the imperfect information section. And how will climate change and the renewable energy transition impact the markets for our products? So there's a lot of understanding right now that the environment is very important, the environmental economics is very important. So if you can answer these questions really well, I think it'll be very employable in the industry. So the structure of a research paper, this is again an academic research paper, though you're seeing a lot of industry research papers that look kind of like this. Start off with an abstract, a broad overview of paper and analysis, followed by an introduction. What is this paper about? Why is it important? Literature review. What have others done? How are you different? Model. How do you think this industry or phenomenon works? Who are the players? What motivates them? What economic theory are you testing or building on? Data. Where's your data from? What makes it interesting? What features characterize the data? Estimation strategy. How do you plan to estimate your model? What statistical models will you use? And results. What exactly came out of your estimation strategy? You definitely don't have to do something this complex. You don't have to do every part of this if you're doing a research paper for this class, but you should kind of make a real effort if you do a research paper for this class to go through the steps of writing an economic research paper and understanding what economic research is. And finally, how do you know what data you need? So we are going to get right into how to find data, but before we try to get into how to find data, I want to talk about how you know what data you need. Data is almost always a major constraint on a research project, so it's very important to know upfront whether or not you can do things and what data are going to be able to tell you. So start off by looking at the data used by others in the field and replicate. This was stressed on me by someone I work with who I think did a very great job of teaching me that replication is very important and you have to do what someone else taught you or someone else did in the literature before you do your own thing. And then think about the level of granularity needed. Granularity is hard. You want to make sure you answer the question you're asking. Ask what in the data answers the question you have, and ask what data is missing. How does this impact your model? So the economists' comparative advantage, economists are not the best programmers, so why hire them to do machine learning? Why hire them to do machine learning? Why hire them to analyze data? Why you? Why not? Why are you going to get a job? First off, economists know data. If you're selling yourself to a boss, say, I know data. I have looked at data. I've been in the trenches with discount analysis. I know the data generating process, and I know data. Economists know the theories that allow them to make sense of data. Economists know causality. Economists have a rigorous approach to statistics missing from machine learning and missing from data science. So just keep in mind that is your comparative advantage. And when you're selling the techniques you're going to learn in this and the next PowerPoint to employers, tell them, I know data, but I also really think about what goes into the data and have a rigorous approach that I think is missing from these other people's degrees. And I hope you have a great day. I look forward to talking to you next time. We'll get into a little bit of R code.